Hey everyone, thank you for joining me. This is the start of a series of videos on expansion and factoring, covering topics such as when and how to use them. Today, we will start with the basics of expansion, specifically regarding the distributive property. Now, in math, the distributive property tells us that if we are given one number that multiplies the difference or the sum of any group of numbers, the result is equivalent, meaning the same, as multiplying the number by each member of that group. So let's break down what exactly that means and how you can apply it. Well, let's take the expression on the left, the one in yellow. So we have this letter A here, and what we're going to do is we're going to multiply or distribute A to every term inside of this brackets. So you can see that we're adding B and C. Here we're going to go A times B plus A times C, which gives us this expression on the right there. Now, if we were to take the green expression, on the other hand, well, the only difference is that we have B minus C, or we're taking the difference of the two terms. A is going to distribute in the exact same way. So we're going to go A distributing to B, and A distributing to C, which gives us A times B minus A times C. Now, before diving into more complex examples, let's start with a pretty basic example, just to showcase that the distributive property does actually work in math. Now, when you see the expression written in cyan, you can solve it in two ways. Now, the first way, probably the more intuitive way, would be to add these two numbers and then go ahead and multiply the sum of those numbers by the number 3 there. So let's do that way. That's going to give us 3 times, in brackets, we're going to have 3 there, which is going to give us 9. However, you may also know now that we can use the distributive property there. So what we're going to do is distribute this 3 to each of those terms. And what this is going to give us is, I'll write expression 2 over here, which is going to give us 3 times 2 plus 3 times 1. Well, we know that this is equal to 3 times 2 is 6, plus 3 times 1 is 3, which gives us 9 as an answer. So this shows that the distributive property does in fact work in math. Now, based off that last example, you might wonder, why do we even bother using the distributive property in the first place if we could just add the numbers inside of the brackets and just have it done with? Well, the reality is, often we're going to have terms that are not alike in the brackets, or unlike terms. Take this example right here. We have x, and we have 1 that we're subtracting from x, or x minus 1. Now, unless we know the value of x in terms of numbers, we can't solve for this expression just by doing that. So this is where the distributive property really allows us to make use of unlike terms. So what we're going to do is distribute the 2 to each of these terms, and that's going to give us 2 times x minus 2 times 1, or just based off of our laws of like terms, 2x minus 2. And this is as far as we can take the expression. We can't solve for it in terms of x because we don't know what it's going to be equal to, and thus we've used the distributive property as exhaustively as we can. Alright, so I have 3 other examples written right here. Each of them is a little bit more complex than what we've covered so far. I would like you to go ahead and try to solve them. I'll give you a few seconds to pause the video and do so, and you can come back here once you've tried. Okay, so let's dive into each of these examples. Well, let's start with orange here. So we have a negative 2, and we're multiplying that by x plus 1. Well, unlike terms, so we can't just add them inside of the brackets. Therefore, we have to use our distributive property. So I'm going to go ahead and distribute that, which here is going to give me negative 2 times x plus negative 2 times 1, or negative 2x minus 2. So similar to one of the previous examples that we got, except in this case, everything is negative just because we multiplied through by a fully negative number. Okay, So let's move on to this next one right here. So 3 times 1 minus x. Well, same concept. We're going to be distributing the 3 here because we have unlike terms. And that's going to give us 3 times 1 plus 3 times negative x. You can put that in brackets if you'd like. Doesn't make a difference. Well, that's going to give us 3. And here we're going to get minus 3x. Just because it's 3 times negative x, which is basically 3 times x times negative 1, we can just move that negative 1 out front. And finally, with this last example right here, we have 4x plus 2y. Well, x and y are not like terms, so we distribute the 4 to both of them. And that's going to give us 4 times x plus 4 times 2y. Well, that gives us 4x, but on the right here, where we have 4 times 2y, that's basically saying 4 times 2 times y, or 8 times y. So we get, therefore, 4x plus 8y as our final answer for the expression on the right. Now, I wanted to end off with this example right here, which showcases that we do have like terms in the outside term and what we're adding. However, because we're not adding them, we can't do the trick that we did before to skip past the distributive property. So we're going to have to distribute the outside x to each of these two terms. Now, that's going to give us x times x plus x times 2. Now, x times 2 is going to be 2x, but remember that x times x is going to be x squared. So that gives us x squared plus 2x as our final answer there. Okay, and that brings us to the end of this video, talking about the distributive property. Thank you very much for your time and for being here with me. I hope to see you again soon.